right, so we're talking databases, and databases are where we store stuff. The first command that tells us anything about databases is show databases. And that gives you a query that gives you back a list of all the databases you have access to. It is also the same thing you see visually on the left-hand side of your screen inside of a SQL client, a graphical SQL client. It's running the command show databases underneath the hood here. So that's it, show space databases. It's the first thing you want to run anytime you connect to a database server. In the graphical interface here, the way to use a specific database is to click on it. Go figure. That's like what graphical interfaces do. Now, the programmatic way to use a database is to use something called a use command. I'll show you what I mean by this. I'll open up a So I'm going to open up a new query tab. If I say show databases, that gives me a list of every database I have access to. But to use a specific database, we would say use and then type out some database name, like employees in this case. Right? That's the same thing as going into the GUI and clicking on that. But you see how when I said use employees, everything expanded under employees. And when I move to use ELODB, ELODB opens up for me. Now, technically speaking, we can talk to multiple databases at a time, and we will sometime next week. But we generally want to use, it's kind of like folders on your terminal. You only have one working folder, one PWD, even if you are able to talk to multiple folders through here, right? Same concept. And that command is use. Now, you may notice that you didn't have to type use on the exercises from earlier. What's going on here? Check this pattern out. The pattern that we're seeing here is we have some sort of select columns from, and we have the database name and then the table name separated by a period. So if you specify the table, the database name itself, you don't have to specify, you don't have to say use this table. We can talk to anything. Just like if you use a relative or an absolute path on the terminal, you can talk to other folders. Cool. I'll dig a little deeper into this. If I say use employees, and then the next line of code, I say show tables. Well, databases are composed of tables. So I'm going to say use employees, show the tables. Now I'm seeing the tables in a database called employees. But if I change my use statement to quotes and then show tables, I now have the result of seeing the tables that exist on the quotes. So use quotes, then show tables. And it's not working for some reason. It's not working because the name of the quotes database is not quotes. The name of the quotes database is quotes DB. I should slow down and read my error messages. So see how it's kind of like a current working folder almost. That's my mental model for it all. The database you're currently using is the database that's currently selected, and you can still talk to other databases if you need to, but you're only selecting one at a time. Yeah.
So if you command enter, like, so in this case, in 3.2, you have more than one, and enter after your table.
Yeah, command enter runs everything,
Do you have to highlight it all?
but I had to highlight it all. And the challenge of highlighting everything and running it is that, see how I didn't get the output back? I'm only getting the output of the first query because it's being a jerk. So we might have to run these sequentially.
Okay, so you just.
Yeah.
Thank you.
Yeah, and if I were to say show databases after this, what I'm going to do is run both of these commands here. and see how only the top one ran. Or they both ran, but only the top one gave us the result. Okay, so just something to keep in mind. We generally want to run one query at a time.
Sorry, Ryan, how did you know only the top one gave you the result?
What's that?
How did you know only the top one gave you the result?
Because author, quote, and quotes and topics has something to do with quotes and doesn't have something to do with the list of every database on the server. Kind of context. And it doesn't hurt the table. You know, but it's context here. Yeah, great.
So mine, the opposite, mine shows everything from
Cool. You got me. It might be a setting, you might have a slightly different version of SQL Workbench than I do. I think the lesson here is don't trust your life to the execution order. All right, cool. Yeah, maybe.
So this blue box, does that mean it ran or does that mean it's going to run?
I don't know is my honest answer.
Okay. But I'm seeing that's like a good thing, getting that's pretty good wrong, so I.
Yeah. A question for Jules?
Yes. So I thought like you put the semicolon at the end of a query so you could run multiple things. And so, for example, if you were going to do like use quotesDB, show tables, and then show data, you know what I mean? Like if it was all related, then at the end of that query, that's where the semicolon would go. Is this because you're actually doing 3 separate things that are unrelated?
Yeah, these are 3 separate queries.
Okay.
Is the, yeah, good question. Good question, Jules. I turned the mic down a little bit. Hopefully y'all are hearing a little bit less reverb. Okay, cool. Right. To see what your currently selected database is, this is kind of like doing PWD on the terminal. The equivalent of it in SQL is select database parens. And you can see what database you currently have selected. And you'll notice this one has parentheses, doesn't it? Because it's a function. It's a function. All right. Cool. We can see at any given time, we can see the SQL that it took to create a given database with the following command, show create database, followed by that database's name. This would be much more interesting if we were doing a database administration thing rather than data science thing, but it's there for reference. Okay, so don't think that this is the answer to everything. In the interest of time, since this is basically clicking around and running a couple of commands, in the interest of time, I'm not going to stop the class and have us work through these 6 exercises. I'm going to go straight into the next lesson. We usually don't do that, but that's like 90 seconds worth of stuff. Right? So what I want to share with you is the tables lesson. Databases are containers for tables. That's the whole point of a database is to hold tables, and each database holds tables that are related. So when I use the employees database, this is an example human resources database, and I show the tables on it. All of these 6, 7 tables or whatever, they're all related to each other. They're supposed to be. But if I were to say use the Superstore database and then show tables on the Superstore, this is a different product entirely. This is a different database. So categories, customers, orders, products, regions. So you'll see one computer, one SQL server can run multiple databases, and each database itself is composed of tables. And usually our tables hold entities, like the entity of a customer. Let's check this out. If I were to say use, I'm already using Superstore. If I say select star from customers, so I'm saying give me everything on customers, and just show me the first 10 customers. That's what I'm doing with this limit here. We see that the customers table has customer ID and customer name, and that's it. So each row here is an individual entity. Tables are composed of rows and columns, just like a spreadsheet, but what we're going to see is that tables are more strict. Databases are more strict than a spreadsheet, because you can go crazy on a spreadsheet. If you have a column of numbers, you can just type stuff that's not numbers in that column, right? And there's ways of controlling for that in Excel, but it's not right out of the gate that way. So we're going to talk about what tables are, the columns and rows. We're going to talk about data types a little bit. We're not going to do a thesis on data types because, again, you all aren't going to be database administrators, but consuming data rather than arranging its architecture. But it's important to talk about these things. We'll talk about some syntax for creating, showing, describing tables, and yeah, pretty cool stuff. So let's talk about our data types here. Within each column of information, each column has its own type of data. We've seen data types in Python already, strings and floats and integers and booleans, right? Well, we have some types in MySQL. We have integers for whole numbers, and we can have only positive integers or positive or negative integers. It really depends. Like if you're keeping a social security system, you're never going to have a negative social security number. So you can have a more optimized system by not allocating that memory. Floats are floating point numbers, and decimals are floating point numbers with a precise decimal, like dollars and cents. If we have only positive numbers, we call that unsigned. And strangely, MySQL doesn't have a true false. It's really an odd duck compared to every other SQL. We use zeros and ones to represent true and false in MySQL. And instead of a 0 or 1 of an integer, and that takes more memory to hold an integer of like 2.5 billion options, I think is the default there. A tiny int has less options, so it takes less memory. So the takeaway so far is different types of numbers will have different types of data types, depending on if the decimals, floats, positive only, or if they're integers. Now we have a couple of types of strings. And why do we have different lengths of these things? It's for memory optimization. So a char is a string that's up to 255 characters. This is great for things like unique identifiers or a product code, an SKU number, somebody's first, middle, and last name might not fit in 255 characters, depending on if they've got a middle name, 2 middle names, 2 last names, etc., right? And we can determine how long a char is. Short for character. A varchar, short for variable character, can go up to 65,000 characters of text. And the reason, again, why we have different lengths here is for memory optimization. Databases for decades have been holding tons and tons of information. And if we used a varchar to store state abbreviation, that would be a waste of memory. It would be inefficient. So that's a motivating factor. If we don't know, if we need more than 65,000 characters of text, we use a data type called a text data type. Now, this would be good if you're storing news articles or blog posts or books or something with lots of text. But again, if you're just storing first name, last name as text data types, you're wasting memory. You're allocating too many resources. Not something that y'all have to worry about so much unless you're designing a database, but it's important to keep that in mind. We also have, yes, Mindy, go ahead.
Sorry, why under our say, like, I guess, why would you use bar chart if it's at more than 255 anyway?
Yeah, something between the bar chart contains links up to 65,000. If you need more than, yeah, basically, we should probably reword that because anywhere between 255 and 65,000 would be varchar. Yeah, that varchar is perfect for first names, last names, addresses, that kind of stuff, but not books.
So kind of disregard that.
Yeah, yeah. Date data is a big deal, and we've got at least 3 kinds of data types we're going to introduce now. The date itself, which is year, month, day. How do you note a database person? They always do year, month, day. Time gives you 24-hour time, and the date time together gives you both. So year, month, day, hour, minute, second. And so you're going to see a lot of logs with a full date time. This is good for access logs and stuff like that. Somebody's birthday is not going to be the date time, but when you made a transaction on the server, that's going in as the date time. All right, let's see, primary keys. All right, here we go. It is entirely possible to have nulls in your data. So null means the absence of a record, an absence of an observation. It's not the same thing as 0, right? In controlling a database table, let's do a show. Let's use quotes. Let's do a show create table on, or let's do tables. What tables exist on the quotes database? Oops. Quotes DB, tables. I'm gonna do select star from authors. And we can see all the authors of quotes. We see first name and last name. And it looks like if I want to see, show the SQL that created this table, we do show create table authors. We'll fire that off and look at what we've got here. I'm going to have to copy this and I'm going to paste it. This is the SQL that it took to generate a table for authors of quotes. And we'll see, we have the following things. Table name is called authors. The ID is the unique identifier. It's an integer that's unsigned, meaning it's only positive. Not null means we can't lack a unique identifier. Auto increment is saying, hey, SQL, you keep track of these things, not me. And we see that the first name allows a null. So if we had a quote from Socrates or Plato, we know one name, but not a first name, right? Or Madonna or something like that. So we have an optional first name and we have a not null on the last name, which is a required. Not null means required. Literally cannot make an entry into that table unless you have a value. And then we see that the primary key is the ID, and then this other stuff is like meta information for what kind of character set you're using. Not anything you got to worry about. Yes, Fred. And then,
How did you comment that out so quickly?
oh, you highlight stuff and command /. Yep. So command / will comment out a single line, but if you have a whole chunk of text or code, command / will comment out the whole thing. And you can use that to toggle too. So pretty cool. So that was highlight everything, command /. Like, same thing? Okay, cool. Right. Table creation, primary keys. Cool, all right. We can create tables. Currently, the databases that you'll have access to are read-only. Next week, we'll be working with a database of your own where you can write tables from scratch, and that'll be a whole other lesson. We got to cover a bunch of stuff between now and then. But it's entirely possible, once you have the right permissions on a database, you can create new tables. And the pattern is create table, table name, parentheses, and then the column names followed by the data type and any modifier. So we looked at one example of a quotes table. Here's another example of a quotes table, create table quotes. We have a column called author first name that allows nulls that is up to 50 characters. Author last name up to 100 characters required. And then the content of the quote is text. So this could be a huge quote, not just a pithy short statement, but something much larger. And then that's not null, meaning that that's required. Oh, I'm gonna check in with the chat. Do you run after every command? Well, yeah, if you want to run the command. I mean, yeah, absolutely. Sometimes where you might not want to run every single command at the same time is if you want to double check a query first, run that separately, and then double check a second query. Or maybe you're copying a query and changing one thing, changing two things. You might want to be nice and deliberate with that. Cool. We'll talk about primary keys and describe, and then let y'all work on the exercises a little bit. Realize I'm going a bit fast on this one, and that's okay because we're not expecting you to be database administrators. Right? We can talk about how using a varchar for a zip code is a better idea than using a text, right? That's about the level of detail we need to worry about right now. Something that's very important that, in my opinion, every table needs something called a primary key. Your primary key is a unique identifier for each row on that table. So think about that like in some systems, your email address is a unique identifier. In other systems, what if you can change your email address? Then that's not the unique identifier, right? Primary keys can be numeric, alphanumeric. They can take many forms. If we were to say, use the Superstore database, and then show the tables for Superstore, and do select star from customers. Which one of those do you think is the unique identifier? Customer ID, right? And that's usually called the primary key. We'll talk about other kinds of keys later, but a primary key, we don't have any duplication of that primary key. It's unique and it points to one row. And it's optimized for speed. So keys have to be unique. Keys cannot be null, and there can only be one primary key of that value in the table. So think of that like as a product number or as a unique identifier. What's that?
That's the primary key.
Huh?
Although
Yeah, no, incrementing is a numeric thing. So when we see AA 10315, SQL isn't able to increment these. That's probably these customer IDs may have existed in some other system. Other times, what if we did show, we'll do show the table employees.employee. Employees, let's see here. Looking at a different table, we're looking at the, oops. At the employees table from the employees database. The employee number is not being auto-incremented here. And that's okay. What matters is that we can't allow nulls in there. Usually if if you were doing greenfield development, meaning you're doing something from scratch, then auto increment is a good idea. Yeah, hey, Fred.
Auto increment a function of the database, or do you have to MySQL?
It's a function of the database or the table itself, actually. Yeah, so SQL is just, it's counting up by one every time you add something.
Okay.
But if it doesn't count by one, don't freak out. SQL knows better than we do. Yeah, I saw a hand from Paige and then Kate.
Hey, I'm not trying to stop the show, but I'm trying to run exactly what you're running in the MySQL, and I get error codes nonstop, like error code 1142 show command denied to user. I don't like my screen looks exactly like yours, and I like can't get why it's not working.
Okay. There's got to be a contextual reason why that's the case, Paige. So let's try this. What is the last command that you tried to run?
So, and that's the other thing. I guess maybe I'm not using it right, but so you run the command after you type everything in. So use superstore DB, then you run it, and then you put show tables, and then you run it, or is it you type all of it in and then you run it?
So what I did right now, I said use superstore database. It's kind of like on your terminal moving to a folder. So I say, hey, SQL, use superstore database. And now I'm going to say, show me the tables that I have access to. And by doing those sequentially, SQL knows that I'm trying to talk to the superstore database before it tries to show me tables. So if you just, if I quit out of MySQL Workbench entirely and I relaunch it and I just say show tables, I'm probably going to get an error because I haven't specified what database. Tables don't live randomly. They can only live on a database. So when I say show tables here, it manages to hang on to the old memory. Okay, that's not a great example. But yeah, you do have to say use.
Right, so then you do use superstores DB, then you do command enter to run it.
Yeah.
Okay, hold on, let me try that because I haven't gotten anywhere close to what you're getting every single time. So that gives me nothing. Show tables.
Because we don't have access to the database.
And let's see. And mine looks different too. I don't know why.
If you don't have access to Superstore database, which might be the case, we can try a different database like, let's do employees. So employees and then show tables on employees. Is that giving you anything different, Paige?
Okay, so yeah, okay, it's working now. Yeah, I just needed to know like the format on how to enter this all in because I think I was just running it after I typed everything out and it was giving me like weird errors and stuff. I just didn't know when to do the running. So I guess it's after each thing you enter. So that makes sense. Okay.
So it's just like on the terminal, we can't do things on files unless we're in that folder necessarily, not so directly. It helps to be in that folder.
So if this doesn't kind of read from top to bottom, I guess, like, is that universally the case? I think the only thing I really see, first thing see is a massive measurement pods in the oil field, where they write this long SQL script.
Oh, yeah.
To bring a whole bunch of data in from my measurement, data out the field. So are they having to, how is something like a big, how does that run over, I guess, that makes sense.
Yeah, show me the first 10 employees is pretty elementary stuff. but show me the first 10 employees who work for sales, who were born on Christmas Day. We build that up piece by piece by piece, one small piece at a time, and we'll be doing that. Y'all will be thinking in those kinds of pieces by this time next week.
So let's say if I write this out and I sit and you're like, hey, Greg, how do you get this? And I sit here and I have this. Yeah, just run that because you're running stepwise, right?
It depends on the query. If your query is self-contained, all I need is use the right database and then have the right permissions and run the query.
Okay, that's interesting.
Yeah, because these are deterministic systems, right? The only thing that would be different is permissions could be different, or if you had a query that was dependent on another query before it, which won't really be the case for a week. Yeah, you're welcome. Hey, Kate, I see your hand. What's on your mind?
I just want to make sure, our primary keys required in a table?
They are not required, but it is silly not to have them.
Okay.
That is a professional lingo term. It is silly not to have a primary key.
And then how often is it that you have primary keys that are same across tables? I'm thinking, like, if you don't need a unique identifier for a table, or a particular unique identifier for a table, and you're using like the foreign keys, which I know we haven't talked about yet, but is there any reason why your primary key can't be the same and that's used across 5 different tables because it happens to also be the foreign key?
Yeah, we'll certainly talk a lot about foreign keys when we get there. You can use the same primary key on different tables as each table's primary key. That's totally good. Your mic cut out a little bit about halfway through, so I don't know if I answered your complete question, Kate.
You did, thank you.
Okay, cool. Yeah, if you'll bear with me on the foreign key stuff, we'll get there Friday, maybe Monday. Let's see. Oh, show tables. We talked about show tables. That shows you the tables you have access to on a given database. You might not have access to every database. We discovered that the unfortunate way. Earlier, I was talking to Superstore, and Paige, being a studious student, was typing exactly what I typed. My apologies, Paige. I didn't realize that we didn't have Superstore shared with y'all. So that's on me. Because we don't have any exercises built around it, some random data set. I think it's a work in progress thing. Now, here's something that comes up very frequently. I want to know something about a table. So let's take a look at, I'm going to use the employees database. And then I want to say, hey, SQL, tell me about this table. And in this case, I'm going to say, hey, SQL, tell me about, with this command called describe the employees table to me. And check out what we get back from this. We get back the column name about the table we said describe this to me. We get the data type, so int, date, varchar, or enum. I didn't talk about enums, but enums are if we have a set of options, then we could use an enumeration, short for enumeration. So if we were modeling stoplights, we could do red, green, and yellow as an enum, as an enumeration of strings. And then hire date is a date. So there's not hour, minute, second on when they were hired. It doesn't matter if they were hired at 9 a.m. or 5 p.m. And then this null column tells us if we allow nulls. And in our role on the data science side of things, we really appreciate it when database administrators don't allow nulls in. But there's also business reasons why there might be nulls. Some people literally don't have a middle name, right? So that would be a nullable optional field. Same thing with a secondary email address. Some people just have one email address. So then you have a nullable field, right? So the describe tells us if we even tolerate nulls on a data integrity standpoint. The key column tells us what kind of key we have. Then we'll talk about the different kinds of keys. There's primary keys, foreign keys, and then those sound very exotic, but all a foreign key is some other table's primary key. And then there's some other types of keys that are composites. So we can make a composite key out of two different columns. And yeah, so describe tells us a lot. And we can use describe on the different tables itself. So I can describe salaries as opposed to the employees table. And we see that salaries has employee number, the salary number, the figure, the from date, and the to date. Yeah.
Ryan, is it correct to interpret it that employee number is the primary key for that? Just
This one's very interesting. This is a little confusing because we see primary twice. What's going on here is we have a primary key that's called a composite. On the salaries table, let's say you're at the same company 10 years, you're going to have the same employee number, even if you have different salaries over time, right? So you have duplicate IDs, but you only had one employee number, one start date on that salary. So combining those two together makes it unique. Yeah. Let's describe. So show tables shows you all of the tables you have access to, and describe tells you about that table, the data types it accepts, if it accepts null, what the situation with the keys is, and it's a good idea. It's a good idea to take a look at that when you're wrapping your head around what kind of data you have. Do you have a question? What is a keychain? I mean, this is literally the same idea. So there is a thing, I'm not trying to make fun of your question. Like it's literally an idea of keeping multiple keys together. There's an application on your Mac called Keychain Access. And that is the part of the Macintosh that keeps your, anytime you save a password, it hangs on to those passwords there. Yeah. So it's an analogy. The name is an analogy. This is what's going on there. Cool. Yeah, question from Jules. Go ahead, Jules.
All right, so just to briefly go back to enumerate, if you wanted to compare the number of something, right? Is enumerate how you would compare, for example, like counting the number of strings or entries in a thing to, that's not how you would do that.
No,
Okay.
an enumerate is a finite set of options in a SQL database. It's technically a data type. We're not going to be building anything with it. The math equivalent of an enumeration is a set.
Okay.
Where we have a finite number of things with no duplication.
Okay.
So we can have a set. So in that employees database, they had the data that was represented there was a gender binary, which is why they used an enumeration with two options. And if we had another scenario where we had a different finite set of options, like traffic light colors, we would make an enumeration of red, yellow, and green. And our enumerations could be what, 5 things, 10 things, whatever, but there's no other options. So
Okay.
it's kind of, you kind of lock yourself into a set.
Thank you.
Yeah, Bert, go ahead.
So the purpose of this is the same thing to gather data. That's also what we're looking for. Like to gather data.
Oh, the purpose of the enumeration?
Yeah, the purpose of learning this. Okay.
Oh, the purpose of learning this, yeah. Let's connect this to on the job stuff. If I know that the database only has the salary information as an integer, then when I get this data out of SQL and put it into Python or something else, then I'll need to use an integer data type. I don't need to use a float, for example. So we're getting to know the types of our data. And this is really important. Like, what if the salary number wasn't not an integer? What if this was a bar chart, meaning text? This would mean that we might have a data integrity issue. Why would we have text for salary figures? Could it be that there's a $sign in there as a character or a comma? Or maybe the salary ranges for the company are given in English, like mid, junior, senior, lead. So it just, we're seeing how the data is actually stored in its raw shape. Oh, does that help a little bit?
Yeah.
Okay, cool. Yeah, that's a good question. Like, how does this even apply to everything else? Yeah.
So that's their, that works in case.
Yeah.
That go into the, we or we.
Bingo, bingo. And this is one of the reasons why businesses and enterprises have been trying to run off of databases for the last however many decades instead of just spreadsheets. Spreadsheets are nice because you can get up, moving quick, right? But then you have challenges with data integrity, corrupt spreadsheets versus very nice, neat, clean databases that can handle millions and millions and millions of rows. Yes. Well, let's see. Describe gives you a lot of information about a table. And I think I showed this to you earlier. You could also see the exact SQL that it took to generate a table with show, create, table, and then the table name. The difference is the describe is a nice query that comes back as its own table, basically. And the show create gives you literally the SQL it would take to duplicate this work. So you could copy and paste this and change the table name and make a new table. All right, so think of a database table as a strict spreadsheet. That's my analogy. When it comes to the nulls or not nulls, we're strict on if we can even have that row in existence or not. And the data types are strict. So we can't just throw a string in a column that's supposed to hold only numbers. And this is how enterprises have been establishing data integrity for decades, instead of just living off the spreadsheet. All right, we've got, you want to take a step back? We've got, we'll release on the exercises. The databases exercises are kind of point, click, run a couple commands, but the tables here, you're gonna copy and paste a bunch of these examples and change the table name or change the database name. Right? So there you have it, folks.